Welcome back to my grade 10 maths lesson number 5. It's about parabola, but before going to parabola, there are certain important maths basics that you must know. Therefore, let's go through that first. You must know thoroughly about exponents and directed numbers, quadratic expressions. Let's see what the exponent rules are. If you multiply a quantity a 5 times, I am using the star for the multiplication sign, then we can show it like a to the power 5. If you multiply a to the power 3 with a to the power 4, what is the meaning of that? So when you have a to the power 3 like this, you are multiplying a 3 times. Then a to the power 4 means a 4 times. So altogether you have 7 a's. So the answer is a to the power 7. So what you have to do is simply add 3 and 4, it becomes 7. When you divide, what do we do? A to the power 5 divided by a to the power 3. A to the power 5, a to the power 3. So you can see this a cancelled with this a. So only 2 a's remaining. That means a to the power 2. So simply what we have to do is subtract 3 from 5. 5 minus 3 is 2. But see the difference here. A to the power 3 to the power 4. Here you can see a 2 times. But here you can see only a 1 time. A to the power 3 to the power 4. So just like this definition, you have to multiply a to the power 3 4 times. A to the power 3, a to the power 3, a to the power 3, a to the power 3. But one of these a to the power 3 has 3 a's. A to the power 3, a to the power 3, a to the power 3, a to the power 3. So you can say altogether there are 12 a's. So the answer is a to the power 12. So in this situation, what you do is you multiply 3 times 4. You have to multiply 3 by 4. But here you are adding the indices. So clearly see the difference between this and this. Many people get into troubles when they don't have a clear understanding of the basics. This is another important thing, directed numbers. We know that when you multiply 2 by 3, these brackets represent multiplication. The answer is 6. But if you multiply minus 2 with minus 3, again the answer is plus 6. So that's also something to remember. But if one of the numbers are negative, answer is going to be negative. Minus 2 times plus 3, minus 6. 2 times minus 3 also minus 6. The same pattern holds when you are dividing also. If you are dividing 12 by minus 2, the answer is minus 6. Because one of them is negative, answer is negative. If both are negative, answer is going to be positive. Now we are going to see addition. We know that 5 plus 9 is 14. But what about minus 5 plus 9? There are different ways to understand this, to remember these things. When one of these numbers is negative, we simply get the difference between them, that is 4, and the sign of the answer is the sign of the bigger number out of these two. So it's going to be plus 4. But in this case, when you don't have a sign in front, it is plus. So plus 5 minus 9. So difference is 4, and the sign of the bigger number is negative, therefore minus 4. When you are doing this one, minus 5 minus 9, when both are negative, you simply add them, that is 14, the answer is always going to be negative. When I was in my grade 8, 9, I had a difficulty in understanding these directed numbers. But one day I saw a book, some old book. it explains these things using the concept of loss and profit. Now in this case, it's like you lost $5 and you gain $9. What is the net result? When you are going somewhere, you lost $5, but you found another $9 on the road. So actually you didn't lose anything. So you still have a profit of 4. You found $5, but you lost $9. So the net thing is you have still lost $4, so minus 4. So loss is negative, profit is positive. Now in this case, you lost $5 and again you lost $9. So the net result is you lost $14. In addition, you can do it using a number line also. Let's say minus 5, 9, plus 9. So you can draw a number line, 0. You go to minus 1, minus 2. So you are here minus 5. Plus 9 means from minus 5 you are adding another 9 units. So you end up at 4. So using a number line also you can do. Those are the different ways of thinking about that. If you have difficulty, look at this again before going to the next one. Now we know that 5 plus 9 is 14. Similarly, you can put an x there. Instead of 5, you can put 5x, 9x. So the answer will be 14 and then you simply put another x. Same is true with this. Not only x, we can put x squared. 5x squared, 9x squared. So the answer is minus 5x squared. Now let's go to our next section. That is our expanding lesson. Part B, expanding. Perfect square and completing the square and factoring. Let's first see expanding. 2 plus 4, the whole thing multiplied by 5 plus 7. We know that 2 plus 4 is 6 times 5 plus 7 is 12. So the answer is 72. You can do that in a different way. Carefully look at this. You can first multiply 2 and 5. Here. 2 and 5. Plus, then you multiply 2 with the 7. And then let's go to the bottom. 4 times 5 and 4 times 7. And then separately add the results. 2 times 5 is 10. 2 times 7 is 14 and so on. And you get 72. So same results as before. Now you will see why I explained that. When you come to this kind of multiplications with algebraic expressions, you do the same thing. X times x, x squared. X times 3, 3x. 2 times x, 2x. 2 times 3, 6. You have to follow the same procedure, same pattern all the time. And 3x and 2x we already know will be 5x. So that is our expanding. Some people call it foiling. Let's do that for this. X squared minus 3x, 2x minus 6. So minus 3x plus 2x become minus 1x. We don't write 1 usually. Now our next topic is perfect squares. We know that 16 is a perfect square because 16 is equal to 4 times 4. Or 4 times 4 is 16. So when you multiply the same number 2 times, you get the answer 16. Therefore 16 is called a perfect square. Let's multiply these two and see what happens. X plus 5 multiplied by x plus 5. X squared, 5x, 5x, 25. So this is your answer. So we got this expression when we multiplied the same expression twice. Therefore, this is called perfect square. This expression is called a perfect square. Let's do this. Let's do it for this. Then you get x squared minus 9x minus 9x plus 81. So this is also a perfect square. What do you notice about perfect squares? The last term 25, if you get the square root of 25, that is 5, 5 times 2 is 10. Square root of 81 is 9, 9 times 2 is 18. So you can easily identify a perfect square by checking that result. By keeping that in mind, let's go to completing the square. So this is also something that you are going to use in your parabola lesson. Now you can see that this is not a perfect square because the square root of 35 is going to be close to 5.9 something, but 5.9 times 2 is not 10, so this is not a perfect square. So therefore, in your parabola lesson you are going to do something called completing the square. Let's do that first and see what will happen. This is the procedure. First you write your 35 a little bit away from this one, 35. Next step, you take the half of 10 and square it. Half of 10 is 5, 5 squared 25. You add 25 and subtract 25 so that you did not do any damage to expression. And then you shift this minus 25 a little bit towards this one and underline these three expressions, these three terms. Next step, now we already know that this x plus y squared, this little piece is a perfect square, and then add these two, it becomes plus 10, and this is called the vertex form of a parabola. You will know that later, vertex form. So we have completed the square. This process is called completing the square. In this introduction, the last section of this introduction is factoring. What are the factors of 6? Factors mean we are breaking the number 6 into two pieces, something multiplied by something, not something plus something. So 1 is 1 times 6 or 2 times 3. So the factors of 6 are 1, 6, 2, 3. Now let's leave it for a while and look at this one again. Let's multiply these two expressions, we get this. But in algebra we have to sometimes go from here to here. That process is called factoring. So we have to factor this expression to get this one. Let's see what the procedure is. First we put some brackets like this and put x and x. And then we write down the factors of 6 like this. 2 times 3 or 1 times 6. And we have to put these numbers here, 1 and 6, 1, 6 or 2 and 3, and see whether we are getting the middle term 5x, like here 2x, 3x. That's how you check the middle term. So looks like you are getting the middle term, and then you have to carefully select the correct sign so that you get plus 5x. So the factors of this expression is x plus 2 and x plus 3. We call them factors because this expression is equal to something multiplied by something. So these are factors of this expression. Common factors and difference of squares. Now if you have expression like this, we can simply take the 2 out of the bracket. We put a bracket and then say, because 2 is common to both terms, and then become x plus 2. If you remultiply, you get 2x and 4. And now I'm going to show you the difference of squares. Before that, let's multiply these two expressions. Something minus 6, something plus 6. What do you get? X squared plus 6x minus 6x minus 36. They cancel out. So the answer is x squared minus 36. So 36 is a perfect square. Therefore, we can see that the factors of this expression is going to be x minus 6, x plus 6. Let's try one more. If you expand this, you get this. Cancel. And the answer is x squared minus 49. So the factors of x squared minus 7 squared is x minus 7, x plus 7. Same thing here. X minus 8, x plus 8. This is another example. If you see a question like this, what are the factors of this one? We know that 50 is not of fx square. But first of all, you have to take the common factors out. 2 out, then it become a squared. 2 out here, it become 25. Now, 25 is a perfect square. We can say 5 squared. Sorry about this spelling typing mistake. 5 squared. So we already have one factor. This part become a minus 5, a plus 5. And finally, we are going to see a little bit of quadratic functions. In our previous lesson, you saw the graph of linear functions, y equals x plus 1. Now today we are going to see a quadratic function, y equals x squared plus 1. X squared means x times x plus 1. Y equals x squared plus 1. Let's make a chart. When x is 0, 0 squared plus 1 is 1. When x is 1, 1 times 1, 1, 1, 1, 1, 2. When x is 2, 2 squared, 2 times 2, 4 and 1, 5. And minus 2 squared, minus 2 times minus 2 is 4, 4 plus 1, 5. So same thing for the other number. Now we are going to put the numbers on a graph. X equals 0, y equals 1. X equals 0, y equals 1. X equals 1, y equals 2. X equals 2, y equals 5. Okay. And same thing for the negative numbers. Minus 1, 2. X equals minus 2. The answer was plus 5. So when we connect all these points, we get a nice parabola. And in our next lesson, we are going to see different situations in these parabola lessons. Thank you for watching.